So hey everyone, I'm back after a very long time, and I suppose it's a good time to restart and start remaking videos again. So today I have a very interesting topic that really grabbed my attention while I was trying to study the history of mathematics. And the concept or the topic I came overthrough was something called Zeno's paradoxes. So recently, when I was preparing for my maths exam, I got interested in uh, thinking about how did calculus emerge, like how did mathematicians actually find calculus and how it was actually derived. What is the historical background of deriving calculus? So I dug deep and I went all the way back to maybe 300 BCE. And then I heard about this man called Zeno. Now, Zeno was a student of a philosopher named Parmenides. Now, Parmenides had a very specific philosophy that everything is one, reality is continuous, and motion is an illusion. Now, this seems contradictory and absurd, and his contemporaries also called him absurd for making such a point. But Zeno, for the sake of defending his teacher, he gave a set of paradoxes that challenge our common sense, such that uh, he tried to prove his teacher right by trying to prove us wrong, our common sense wrong, that the idea that motion is true and reality is not a constant but made of multiple parts is itself contradictory and creates contradictions that are just as absurd. So let's get into it. So he provided a bunch of arguments. So the first argument he provided was the argument of denseness. Now imagine two objects, object A and object B. What is the thing that is actually separating these two objects? Well, is it the space between them, or is there nothing between them, or is there something between them? Well, if there is nothing between them, then these objects must be one, which is not true because these objects are separated. But what is separating them? There must be something in between them that is actually separating them. So now we have actually three objects, two objects here and one object in the middle that is separating these two objects. Now we have three objects. Now the question is, what is separating these three objects from each other? Two more objects, and you can see where this is going, that we need an infinite amount of objects to separate two objects. So there can be no just two objects, there are infinite number of objects in a specific space. So there can't be two objects, there are an infinite number of objects in a specific space, as this argument says. Now this creates a contradiction, because if there is nothing between two objects, then isn't it the same as just one object, because there is also nothing between them, nothing between a single object? So this was paradox number one, and it really intrigued me, and I couldn't find a logical answer myself on uh, how I can myself answer this paradox and myself solve this paradox. So the next one is also slightly interesting. The next one is called the argument of finite size. So now let's imagine an object. There is an object and you divide it infinitely. What is left? Is nothing left, or is there is something left? Well, this creates two logical problems. If there is nothing left, so zero, when we divide an object infinitely, how can a number of a lot of nothingness create something? If we take an object and divide it infinitely into as many parts as possible to infinity, now this creates two conclusions. Either there is nothing left or something left. If there is nothing left, then how can a bunch of nothingness make something? But if there is something left, since we are dividing it infinitely, shouldn't multiplying something by infinity lead to an infinitely large number, not a discrete number? If I take this object and divide it infinitely, but if there is something still left after dividing it infinitely, shouldn't that positive quantity, when multiplied by infinity, also equal to infinity and not just this discrete object? Now, I know this might sound a little confusing and just I'm slipping on my own words here because it's pretty confusing and it took myself a month to understand this concept. But this outlines two logical inconsistencies in our common sense relating to motion and discrete space. Now, the third argument is also interesting. Well, third argument is the same as the previous argument about complete indivisibility. Complete divisibility, which is the same as, but this time Zeno makes use of points. Basically, you can think of it the same as the previous second argument of complete divisibility, the second argument of finite size. Now, later on in medieval times and after the post-scientific revolution, mathematicians like Cauchy and George Cantor proved that infinity is not intuitive at all. In fact, it is counterintuitive. For example, the sum to infinity of a particular number sequence in which you keep dividing things lead to a discrete answer. For example, asymptotes, for example, or when the common ratio between a geometric progress of two terms is less than 1, or between 1 and minus 1, I think so, or between 0 and 1, then they don't lead to infinity. In fact, they converge on a common number. Now, that was a really fascinating concept I came over through, and I think you find this video helpful and didn't find it annoying for me to stutter. I'm still a newbie on YouTube and I just try to improve my teaching skills and learning skills to making these videos. I hope you liked it. See you later.